Hi, today we're going to be looking at practical applications of trigonometry, and we're going to focus on the angle of elevation and the angle of depression. If you look at the diagram and we look at the notes that are coming up, the angle of elevation, it is the angle from the horizontal upward towards an object. And if we look at the picture, there's our horizontal, and now looking at the aeroplane, this forms the angle of elevation. The angle of depression is the angle from the horizontal downward to an object. Looking at the picture we'll look at a man looking at the dog. So from the horizontal, the angle of depression is formed to the dog. We're going to look at some examples. The first one, a man stands at a point P, 45 meters from the base of a building that is 20 meters high. If we look at the diagram, we have a building 20 meters high, and the man is standing 45 meters from the base of the building. The first question wants you to find the angle of elevation of the top of the building from the man. So there's the man, and he's looking at the top of the building. So we look at angle P, which forms our angle of elevation. So we're going to find, or our mission is to find angle P. I want to remind you of saut, car, toi. We've done this in class. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. If we look at our diagram, firstly, we need to note what is given. The 20 meters is given. In terms of the triangle and looking from angle P, 20 is your opposite side. 45 is your adjacent side. Which trig ratio has an opposite and adjacent? Let's quickly look up. Tan, toi, tan is equal to opposite over adjacent. So we're going to use the trig ratio tan to find angle P. So we can say tan P from here is equal to opposite, which is our 20, over adjacent, which is 45. We're now going to use our calculator to find angle P. We're going to use shift tan 20 over 45. Let me say that again. Shift tan 20 over 45. And if we do that, we would get angle P, which is equal to 24 degrees. And angle P, please note, is our angle of elevation. The next question was to find the angle of depression from the top of the building to the man. And you will notice that I put 24. So how did I get 24? The angle of elevation is equal to the angle of depression. And the reason is alternate angles. We have two horizontals that will be parallel to each other. So therefore these two angles are equal. So I want you to remember that the angle of depression is equal to the angle of elevation in this diagram. Let's look at another question. Beautiful picture. I wish I was on that boat sailing away. But let's get back to reality. A 25-meter tall lighthouse sits on a cliff top 30 meters above sea level. A fishing boat is seen 100 meters from the base of the cliff, vertically below the lighthouse. Find the angle of depression from the top of the lighthouse to the boat. If we quickly construct the diagram, we have the lighthouse, we have the boat, and putting it into context of a triangle, according to the question, a 25-meter tall lighthouse. So we know that's 25 meters. Sits on top of a cliff, which is 30 meters. So we get our 30 plus 25, giving us a total distance of 55 meters. We're also given it is 100 meters from the base. So from the boat to the base of the cliff, we have 100 meters. And the question is to find the angle of depression. Now if you remember from the first slide, the angle of depression is from our horizontal looking down. So very quickly, if I put that together, From our horizontal looking down, we have angle D. But remember in the previous problem, we said the angle of depression is equal to the angle of elevation. So we can call this angle D as well. Now, looking at our triangle we have, if we look at from angle D, what is given in this triangle? And if we look at it, and I'm going to go back a little, from angle D, 55 is opposite angle D. And 100 is the adjacent side. Now, which trig ratio from SOHCAHTOA has an opposite and adjacent? I think you're right. It's tan. So tan of angle D is equal to the opposite, which is 55, over 100, which is the adjacent. We're using tan, TOA. And for us to find angle D, we're going to use shift tan 55 over 100. If you type that in, shift tan 55 over 100, we would get angle D to be 28.8 degrees. So this angle D is 28.8 degrees, and it's equal to the angle of depression, which is 28.8 degrees. We're going to look at one of the questions from our textbook that we're using in school. I must apologize for the writing. And the question says, an architect design of the front of a house is given below. The length of the house is to be 10 meters. It's on the diagram. An exterior stairway leading to the roof is to form an angle of elevation of 30 degrees. It's in the diagram. The slanted part of the roof must be 7 meters. We see our 7 meters here. And the first question is to calculate the height of the vertical wall. So they want us to find DE. If we quickly zoom into this triangle that has DE, let us look at what is given. We have 10 meters and we have an angle. And they want us to find DE. So we're going to look at from the angle of 30 degrees, we want to find DE. DE is our opposite side. And 10, the given side, is the adjacent side in this marked triangle. Which trig ratio has an O and an A? SOHCAHTOA. The O and A belongs to tan. So we can conclude that tan of 30 degrees is equal to opposite, which is DE, over adjacent, which is FE. And we know FE is 10. So it's DE over 10. As you can see, I have this. To find DE, we need to cross multiply. DE is equal to 10 times tan 30. Typing that into your calculator, 10 times tan 30, we end up with DE to be 5.78. We're going to move on to the second part of this question. Second part of the question says, calculate the size of theta, the angle of elevation of the top of the roof A, from the ceiling BCD. So we're looking at the horizontal BCD, and they want us to find angle theta. Now, let's zoom into triangle ABC. And before we do that, we know that FE is 10. If FE is 10, then BD is 10. These two triangles are congruent, 90 degrees. The hypotenuse are equal, and there's a common side. That's a right angle hypotenuse side. If they're congruent, it means that BC is equal to CD. So we know that's 5 and that's 5. So if we're looking at triangle BCA, we're trying to find theta. So from theta, 5 is your adjacent side. We're also given 7, which is your hypotenuse. So we need to find out which ratio has an A and an H. Coming to SOHCAHTOA, we have cos, which is equal to adjacent over hypotenuse. So cos of theta in the triangle ABC, adjacent is 5, hypotenuse is 7. So we can conclude that cos theta in this triangle, it's a right angle triangle, is equal to 5 over 7. We want to find theta. If we're finding an angle, we use shift cos 5 over 7. And typing that on the calculator, shift cos 5 over 7, we get 44.4 degrees, which is our angle of elevation sitting right here, known as theta. The last part of the question says calculate the length of the beam AC. From our previous question, remember that we concluded this was 5. We now have a right angle triangle, 5, 7, and to find AC we have two options. We can use trig, we can use opposite adjacent. Well, actually we can also use opposite and hypotenuse, or we can just use Pythagoras. So I'm going to quickly use Pythagoras, considering the fact that it's a right angle triangle. So AC squared is equal to the hypotenuse squared, which is 7 squared, subtract 5 squared, and 49 minus 25 is 24. And then we're going to find AC, which is the square root of 24, which is 4.9 meters. I'm rounding off to 1 decimal place. Remember, you need a reason for saying AC squared is equal to 7 squared minus 5 squared. Our reason will be Pythagoras. Thank you for tuning in on angle of elevation and depression. I hope nobody is falling down or nobody is depressed after this video.